Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're here to do the final segment on the KT88 build, and I think this thing turned out really awesome. Did a couple of small tweaks since the last video. It's kind of a final thing. I put one of these little 1-inch screens here, kind of to fill in this dead space here and to give a little ventilation for the power resistor that's sitting about right here. And then on the underside, got some holes drilled right here and some holes drilled back here to kind of help the airflow, you know, across the amp this way and then across and up through these holes here around the tubes. So that's our interior ventilation system. I did measure the temperature of these cathode resistors, and they're running about 130 to 135 degrees Fahrenheit, so they are pretty warm. And that was one of the reasons for putting them up on the top here, was to keep that heat out of the inside of the chassis. This one that's on the inside, I measured it, and it's just under 100 degrees Fahrenheit. So it runs a lot cooler than these cathode ones because it has a lot less wattage going through it. Got a vintage 5AR4, did some tube rolling, and I ended up with a combination of these Sylvania 6EJ7s and then the Treasure KT88-Zs. I listened to the Horizon tubes, and with certain speakers that might be a better fit, but the owner or the person that commissioned this sounds like they're going to be using some types of kind of horn speakers with it. So I think, you know, listening with my clip speakers, that these -Z tubes were a little mellower. I did figure out that if you put a 5R4 GYA rectifier tube, that drops the B plus enough to allow you to put EL34 tubes in, and they'll be running about 85 to 88%, right in around in that range. So you can run both. The EL34 aspect of this is not really optimized for, so it's got a little more distortion, and as I mentioned in the video, certain speakers, hey, they might sound good, or you may have some EL34 tubes you just want to play with, and so that's an option. I would not use KT120s. I don't think this power transformer has enough heater supply, and even if it does, you'd be running them so cool, they're probably not going to sound good. So I would stick with KT88s. There's a whole slew of different KT88s you can try. So anyway, I'm also going to put on the website all of the driver tubes that have the same pinout that you can try swapping into the amp. And I did try some, let me think if I can, I think there's 6JC6As. And they are a little mellower option from the 6EJ7s. And so this seems a little bright, and they might be a good combo with the Horizon KT88 tubes. I didn't actually try, and there's so many options you can try. And there's about a dozen tubes in that list that have either lower gain or more gain or different, you know, you'll see. Anyway, it makes for fun tube rolling. The other thing I did, since we saw the issue with there being a lot of variation in these driver tubes as far as their dissipation points and trying to match a pair of them, I added a couple of voltage jacks here right next to the cathode resistors, and I could have put them up here in the front, but I wanted to keep this clean, and so I put them back here behind the output tubes and just ran a couple of wires up. There's nothing going through those wires unless you're measuring, and so yeah, I didn't think it was going to have any impact sonically to put them back here. And here's a close-up of what that looks like. And I just thought that was a nice feature, so you don't have to go inside the amp to measure it. That's the other bonus of having these cathode resistors on the top like this. You can get your multimeter and put the ground in the center, and then measure each end, and you get the cathode voltage so you can see how the tubes are holding up, where they're biased at. Obviously you can't read the plate voltage. I didn't want to bring 400 volts to the top of the chassis, but you know, there's 40 volts here, and it really, if you're like hyper concerned that this is dangerous, or you don't want to have that, or you're afraid, you know, somebody's going to get shocked, you can always paint over this with that liquid electrical tape, put a couple of layers of that on it, and that'll totally seal it off from prying fingers. But I wanted to leave these exposed so they could be a measuring point. So anyway, let's get this thing hooked up to the audio analyzer suite and see what this thing does. Okay, so let's take a look at the audio analyzer suite testing. And this is our power versus THD. We've got both channels here, and you can hardly see that there's two channels because they are absolutely identical. There's a red and a blue, and you can't see the difference in them. They're right on top of each other. So we've got 0.75% of distortion at 1 watt. At 2 watts, just a breath over 1%. Stays under 2%, up to 5.5 watts. And it starts clipping just after 10 watts, which is right at 3.5% distortion. So the use of this amp is going to be, again, in this 2 to 5 watt range, and you're going to have some headroom of several watts, about 4 or 5 more watts of headroom before the amp tries to clip. And so it's got about 3 watts more headroom than my EL34 amp has. And then here is where this thing really rocks. Look at the frequency response. It's 0 from here down to 40 hertz, and then at 20 we're down 0.27 dBs. And then obviously it rolls off here on the bottom, which is what you want to see. We don't want, you know, subsonic stuff just get totally blasted. And then here on the top end, 10K, it's basically 0. It's down 0.07. And then at 20K, we're down 1.3 dBs. And at 15K-ish, we are down 0.5 dB. So, you know, in this range, there's not a lot of music here up here anyway, so I don't, you know, I've said this before, I'm not real concerned about this range. Down here is where this thing rocks, and man, you can hear it when you're listening to it. It's got some really clean bass. So the last thing we're going to look at is, well, not the last thing. Let's go ahead and look at the THD versus frequency. We're pulling this at 2 watts into 8 ohms. Down here at 20 hertz, we got 6.5% distortion, but then it quickly drops down to just over 2.5% at 40 hertz. And then 100 hertz, we're down to 1.5%. And then, you know, across this whole range here, it's 1% distortion. Now look at the spectrum on the left. I mean, that is a beautiful looking spectrum curve. Let's look at second order harmonics. As you can see, the line almost doesn't move. And then when we plot the third order, which is what you don't want to hear, boom, it drops way down here. So this harmonic distortion we're getting, almost all of it is the good kind that we buy tube amps for. Even down here at 20 hertz, you've only got a 0.5% of third order harmonics. And then in this range here, it's 0.2, 0.25%. And again, the second order, right even with the total. So that's telling me that the vast majority of the harmonic distortion is the good second order type that, again, is why we buy tube amps. So then on the scope, we got 1K square wave. We'll go ahead and pop it again just so you can see this is the amp running. Got a little bit of ringing here on the front end, which honestly I have learned makes the amp sound lively when I've like tuned the feedback loop or, you know, added capacitance and stuff trying to flatten out this. It's just made the amp sound dead to me. And so this little bit of ringing here, and you can see it stops really quickly. That doesn't concern me at all. Let me go ahead and show you the sine wave. Looks beautiful. Let's go ahead and go to 0.8, which is 10 watts of output. Rolls a little bit on the top here, but it's far from clipping. But if we go to 0.9, I think that's probably where we're going to see the clipping start. Yep. You can see right down here on the bottom, it's trying to clip, but it's not really clipping. Let's see what 1 volt does. There we go. That's clipping down here. And you can see this is just about to square off too. So we've got symmetrical clipping for the most part, which is what you want to see. So I would say at 0.9 it's still not clipping. Yeah, I'd say that's still a clean sine wave. So we'll go back to this chart here and look up there, 0.9. We're making 11.5 watts. Close to 12 watts before it starts clipping. That's pretty freaking stout for a KT88 single-ended amp. So let's go back here and look at our other square waves. And then, again, this is our 1K. Let's look at the 10K. And pretty reasonable. I mean, I've seen way worse 10K square waves. I mean, to me, I can live with that. And then we'll drop down to 100 hertz and look at that square wave. And again, little ring here on the front end. This sloped angle here is perfectly normal and they're nice and sharp. Totally happy with that. So again, here's where I'm impressed. And for the price of these 25 watt Edcors to get that kind of bass performance, that's a real bargain. And these really do work well with a KT88 too. And this plot here, and you can see this is both channels. It shows you how even both these channels are. Now the interesting thing, I did swap in those mismatched input tubes and it had zero impact on like this screen showing their evenness, and the same here had no impact on the power production. So I think what happens when you end up with the bias cathode voltage a little different, that you're just swinging the tube in a little different region, but it getting the same swing at the end of the day, and so it makes the same power. So yeah, I'm happy with this thing. I did try adding some more shade feedback. I dropped it down to, I got a 300K resistor in there, and I dropped it down to a 220, and it did drop this down about 0.5 to 0.75% of distortion. But when I listened to the amp, it just didn't have as much life or as lively sounding as it is with a 300K. And again, depends on your speakers, your room, kind of music you listen to, all that kind of stuff. Even as far as different tubes might perform differently with different shade feedback resistors, but I feel like 300K is a nice compromise between trying to minimize the distortion and keeping the tone and especially the upper end of the range sounding lively. So yeah, I think we're done here. It's like a great place to wrap up this video. Well, as you can see from the testing, this thing has insanely good frequency response. And listening to the amp, I can concur that it's a really good sounding amp that's got a really smooth across the range frequency response. I didn't hear any like dips or brightness or any portions that seemed out of place. Obviously, rolling different tubes in will affect the sonic signature of it. And like I said in the first segment, you can put a 5R4 GYA rectifier tube, put EL34s, 6CA7s, KT77s, KT66s. There's a whole slew of those 25 watt rated tubes, 8-pin guys with the same pin out that you can roll in this amp with the other rectifier tube. And of course, if you put a 5AR4 in it, there's a whole slew of these higher rated tubes. You should be able to run some 6L6 GCs, and make sure you measure the dissipation. That may be kind of pushing the limit on those, but I think that would still be under 95% running a 30 watt tube with the 5AR4. You should be fine. If not, you could potentially find another rectifier tube that'll pull down the B plus just a little less than the 5AR4, like a 5V4 would probably get you there. And so, yeah, there's a whole bunch of stuff you can do with this amp, which one of the reasons that it's really fun. Also, you want to make sure if you're going to put these tube rings that you use this bigger one on the rectifier tube. This small one, the inner diameter is too small to put a 5R4 rectifier tube. Plus, I think it just looks better with these big rings to have this one a big ring too. So, anyway, I think this has been a fun project. Shows to me how good these Edcor 25 watt 5K output transformers are. They've got a really good low frequency response. I did find in my 300B putting the ISO Tango iron in replacement of these was another sonic improvement. But for a budget amp or one built in this price point range, these are a great buy. And scuff them off, paint them black. They match the Hammonds. Everything looks nice. Got my little cookie badge. And obviously, or I hope obviously, if you wanted to make this an integrated amp, you could put a volume control up here in the front between the input jacks and the grids of these input tubes. And you could have an integrated amp where you can control the volume. This guy wanted a power amp because he's going to be driving it with a preamp. I did listen to it with my color preamp, and it sounds really good too. So that's another option. And it does like the extra drive. Anyway, hope you've enjoyed this series. If you have, please subscribe to the channel. Please like the video. Thanks to all you Patreon supporters and folks that make donations. If you build one of these and found this useful, consider dropping me a donation at my website for helping you figure this out and for the plans that I'm going to put on the website. As always, all these projects I build, even for customers, are open source, and I put the schematics, BOM, everything on the website. Give me about a week or so to get the BOM up and get a schematic drawn up for this. I know, I probably should have done it, but I really wanted to wait because some of the things, I just finished deciding today what the feedback resistor was going to be. And I did a combination of listening to it and looking at the measurements. And it just sounded better to me with a 300K feedback resistor, even though it costs a little bit in harmonic distortion. I could have gone down to a 220K, probably maybe even got 0.75% less harmonic distortion across the whole range. but it just didn't sound as lively. It sounded a little muffled to me. And so that's one of the things that you have to decide for yourself. A good way to play with that so you can try to A/B this stuff fairly quickly is put something like the 300K resistor and then bypass it with a 1 meg, and that gets you down to like 230, and then listen to that, then clip that resistor lead, and then listen to it again. And that allows you to get more of a back-to-back listening than if you were having to take it back down to the bench and solder in other resistors and then go back, because by then it's hard to remember what it sounded like. And obviously it's easier if you can just flip a switch. One of my amps, I did have a switch to switch between the different feedback resistors, and that's an option if you want to DIY it that you could do, is put a DP-DT switch somewhere on the amp that switched in 2 different values of shade feedback resistors. So you could kind of A/B, dial in the sound you want. So anyway, I think that's enough on this amp. Again, hope you enjoyed this, and until the next video, have a nice day.